Here, and these last two sections are just covering some skills that were not covered earlier in the review guide. So some miscellaneous skills, first from the linear functions chapter and then the kind of general functions chapter. So let's take a look at number 38. And all we need to do here is find the equation for the line containing the points -9, 4 and 7, -8. And eventually we're going to have to put our equation into slope-intercept form. So let's not forget to do that. Well, the first thing I think we're going to want to do is we're going to want to find the slope of our line, the rate of change for that y value. And one thing I sometimes do to kind of help myself remember what's going on is I might label these points x1, y1, and x2, y2. It just helps me remember what's going on. And then we recall that the way to find the slope of a line, or the rate of change, is, well, you're going to find the change in your y values, and you're going to divide that by the change in your x values. That'll tell you how quickly is that dependent variable changing. Well, the change in the x values, the y values, well, we start with our final y value, and we subtract from it our initial y value. And for our x values, we start with our final x value, and we subtract from it our initial one. So we're going to subtract -9 in this case. Okay, so we end up with a numerator of -8 minus 4 is -12, and a denominator of 7 plus 9, which is 16, and this is going to reduce to -3/4. So the slope of this line is -3/4. So let's use this information and then one of these two ordered pairs to create the equation in point-slope form. So maybe let's use this ordered pair, -9, 4. And so hopefully we know how to use this information to create our equation. So our equation, and that's going to be y minus 4 equals -3/4 times the quantity of x plus 9. All right, so the hard part is done. We've created a line that definitely has a slope of -3/4. And if x were -9, and y were +4, we would definitely get a true statement, so that point is on our line. And so all we have to do is put this into slope-intercept form. And first thing I would do there is I would distribute this -3/4. We're going to have some fraction stuff here, but that's okay. -3/4 x minus 27 over 4. The last thing we need to do is add 4 to both sides. And we're just going to note that 4 is the same thing as 16 over 4. We're just going to try to get those like denominators so we can actually add those two fractions. All right, so we end up with a final answer of y equals, let's see, -27 over 4 plus 16 over 4 should be -11 over 4 minus 3/4 x. Awesome. Okay, moving on. Now we are given an equation, and we're just asked to graph it. Now this doesn't seem so bad, right? Oops, excuse me, let's get rid of this thing. Later. Remind me tomorrow. Okay, and all we're asked to do is graph it. Now, we might have the impulse to go ahead and put this in a slope-intercept form. But let me tell you, doing that is not going to be very helpful because we're going to end up with y equals, let's see, we're going to 12 minus 21, so -9/7 minus 3/7 x. I think I did my math correctly. 12 minus 21, yes. And check it out, this y-intercept, -9/7, not very nice to graph. So I'm not feeling very confident about using that form of the linear equation. But what we can do is realize that from our original equation, we can determine first the slope of our line. We can tell definitely the slope is going to be -3/7. So that's very important information. But we can also find a point on our line. And my claim is that from these two bits of information, we know that our line is definitely going to contain the point 4, -3. And check it out, right? If x were 4, that becomes 0. This whole side becomes 0. And if y were -3, that side becomes 0. We get a true statement. And so this point is definitely going to be on that line. And so what I would do here is, of course, first things first, label our axes. I would start by graphing this point 4, -3, so 4, -3. And then we can just use this slope right here, -3/7, to kind of find some more points. So for a 7-unit increase in x, so if we were to go to the right 7, we're going to be off the graph. 1, 2, 3, 4, 5, 6, 7. We're going to see a 3-unit decrease in y. So 1, 2, 3. So we got the point like 11, comma, -6. And so I know we don't like to do any eyeballing, but I'm going to put that one there anyway. But we can extrapolate to the left as well. So for a 1, 2, 3, 4, 5, 6, 7-unit decrease in x, we would have a 3-unit increase in y. So 1, 2, 3. Look at that, a very nice x-intercept in this case. Did not see that coming. And we can continue 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, awesome. And we have our line. Oops, that's not what I want. I want a nice line. Well, we'll have to make a new one. And using that super cool strategy we talked about earlier. And now we're just going to kind of make this one bigger and bigger until it is sufficient. All right, boom. There's our line right there. Let's go ahead and label it with its equation. That is the line y plus 3 equals -3/7 times the quantity of x minus 4. And check it out. Remember that y-intercept that we found earlier? That y-intercept of -9/7, -1 and 2/7. Boom! Look at that y-intercept. It totally confirms what we did earlier. So 0, -9/7, and it happens to be that our x-intercept is a very nice ordered pair. That was lucky. -3, 0. Okay, moving on. Number 40. Oh, so here we go. This is just a question all about function notation, and can we interpret this statement that f of x equals 3x minus 5? Well, this is just saying that this is a rule. This is a function with an input and an output, and it's basically saying, listen, whatever your input is, to find the output, multiply that input by 3 and then subtract 5. That's it. That's it. So in this first example, f of -7, it's just saying, listen, if -7 were the input, what would the output be? And you say, well, I know what my rule tells us to do. It says, take that input, multiply it by 3, and subtract 5, right? We're just replacing that input variable x with a -7. So you get -21 minus 5 for a grand total of -26. So f of -7 is -26. If -7 is the input, -26 is the output. Same thing with 12. We're just going to go ahead and substitute in 12 for our input variable in our functions rule. So 3 times 12 minus 5, 36 minus 5 for a grand total of 31. So we'd say f of 12 is equal to 31. When 12 is the input, 31 is the output. Now this last problem is asking us a slightly different question. It's saying, imagine there was some mystery input D that we don't know what it is, but that input gave an output of 22. What is the input? Well, we say, okay, imagine 22 were the output. Well, if 22 is the output and D is the input, well, we know what the rule is. The rule says multiply the input by 3 and subtract 5. And now we've got a nice, easy equation to solve. So we had 5, 27 equals 3D, D equals 9. And we can confirm that if the input were 9, and we substituted that in right here, 3 times 9 is 27 minus 5 is 22. So f of D is definitely going to be 22. So that was a kind of tricky problem. It's all about just interpreting what is the question even asking. All right, last one. So here we go. Here we've got a function's graph, and that function's name is mark. And we need to find all of these kind of input-output pairs, all this information. So for instance, mark of -4, it's just saying if -4 is the input, what is the output? Well, let's take a look. So if -4 is the input, let's see what happens. Okay, we'll drag it. It looks like -3 would be the output. So I would say that mark of -4 is -3. Mark of -1, well, let's look for -1 on our input axis. Mark of -1 looks like it's about -4. All right, mark of -1 is -4. Mark of 3, so we got to find 3 on our input axis, and oops, excuse me. Looks like about -5 to me. All right, so mark of 3 we're going to call -5. If 3 is the input, -5 is the output. Mark of 0 So if 0 is the input, looks like -3, once again, will be the output. All right. Now, these last two are saying, if the output were -5, what could the possible inputs be? All right, so if the output were -5, so let's write -5 on our output. So there's -5. And, oh wow, it looks like we've got a couple of x values. We got this one, which looks like about -3.5. This one, which looks like about -1.5. This one, which looks like about 2. And then we actually did this one earlier. That one looks like about 3. So I'd say if the output were -5, the input could be -3.5. And I think we said -1.5. It could also be 2, or it could be 3. So lots of different inputs can give the same output. Still a function. Still totally a function. And if the output were 4, what could the possible inputs be? Well, here's an output of 4. And I see that that happens here right at about, we'll call that -4.5. And out here we'll call that +4.5. Well, that's coincidental. So I'd say that n could be -4.5 or +4.5. All right, so as you made your way through this, if there were any problems in particular that gave you extra difficulty, that's a great place to focus and try doing one of the problem sets over again to practice that skill and make sure we're ready to go for the exam. So I hope you enjoyed, and I hope you found it helpful.